Okay, so in this video, we're going to look at multiplying and dividing radicals. And the two basic ideas that we need to start with is we talked about how if you have the square root of a times b, that's the same as the square root of a times square root of b. Well, in the same way that we use this to say like the square, we use this to say something like the square root of 24 equals the square root of 4 times the square root of 6, which is 2 root 6. You can use it in the opposite direction. And so you can use it in an example like this, where you have the square root of 7 times the square root of 14. That's going to equal the square root of 98. Now, anytime you do this, you need to consider, is this going to be simplified? One way to know that it's going to be simplified is if you see a factor that's in both of the radicals. Right? In this example, there's a 7 in both of them. So it makes sense that 98 is going to be divisible by 7 squared, or 49. And so we do need to go through and finish this problem by simplifying. Occasionally, we will have example problems where we have something like 2 root 5 times 4 root 15. In this case, the 2 and the 4, these are rational numbers. They are coefficients of these two radicals, and they can be multiplied together. We can't multiply 2 times root 5. We just leave it as 2 times root 5. We don't do anything with it. But the 2 and the 4 can be multiplied together to simplify to 8 root, and then 5 times 15 is 75. We see that 25 goes into that, and so that simplifies to 40 times the square root of 3. If you want to see that worked out a little bit, that would be 8 times square root of 25 times square root of 3, which would give you square root of 25 is 5, 8 times 5 is 40, 40 times the square root of 3. The also involved in these, you can have variables. One difference between these problems, if you read carefully the directions in your book, is that we've told you now that all of the variables represent positive numbers, so you no longer have to concern yourself with absolute values. So for this section, for section 11.7, you don't need to include absolute values in your answers, because we're assuming that the variables are positive already, so we don't need to say that the absolute value of it. So for something like this, we might have a problem, where you've got 3a times 6a to the third b times 2 times the square root of 10 a squared b to the third. Okay. Well, what you want to do to start a problem like this is multiply what's outside the square root together with multiply what's inside the square root. 3a times 2 gives you 6a. When I multiply these together, we get 60 times, add exponents, and so it's a to the fifth. B times b to the third is just going to be b to the fourth, right? Because b is like b to the first. It's just the exponent rules that we should know well. Now we need to go through and simplify the radical and see what we're going to multiply 6a by. Well, 4 goes into 60 15 times, so you're going to take a 2 out, so that's going to give me 12. When I divide and that leaves a 15 inside. When I divide 5, the exponent here of a, by 2, because I'm taking the square root of it, I get 2 remainder 1, and so 2 of the a's are going to come out front, giving me a to the third, because I already had 1 a that was out front. And then 1a really remains behind because we had remainder 1 when we divided by 2. And then we got b to the fourth, which simplifies just to b squared. So the correct answer here is 12a cubed b squared times the square root of 15a. All right, the second thing we've talked about some is we did this, and that was if you have square root of a over square root of b, that equals square root of a over square root of b. Well, this was useful when we had to, evaluate something like 4 over 25. Well, that's just taking the square root of 4 over the square root of 25. We don't have to come up with a fraction. The fraction just appears when we do square root of 4 equals 2, square root of 5 equals 5. Problems we'll deal with now is going to involve this idea, except two things are going to happen that is different than we've done before. Number one is we're going to multiply them together, which we'll do exactly like we just did the previous example problems. And then number two, we're going to deal with scenarios that are more like this, where you have the square root of 1/7, for example. where the square root of 1/7 just turns out to be square root of 1 over square root of 7, which equals 1 over the square root of 7. And what we're going to learn about, or what we're going to do, is we're not going to allow there to be a irrational number in the denominator. So what we do is we need to rationalize, make the denominator a rational number, and we call it rationalizing the denominator. And there's really good reasons that we do this that we'll get to later in this chapter. And so just trust me for now, this is an important step in what we do. So the key to this is taking advantage of square roots. And what we know is the square root of 7 times the square root of 7 just equals 7. So to rationalize this denominator, you just multiply the top and the bottom by square root of 7. And you can do that because the square root of 7 over the square root of 7 just equals 1. So and you can, using multiplication properties, we can multiply something by 1 without changing its value. So when I multiply this out, square root of 7 times square root of 7, that just equals 7. 1 times square root of 7 is square root of 7, so the numerator is square root of 7. The denominator, again, square root of 7 times square root of 7 is 7. And so this equals this. This is the simplified version of the square root of 1/7, root 7 over 7. Just a couple other examples of this. If you ended up with a problem like this, maybe the square root of 6 times the square root of 2 all over, or actually, let's do it this way. The square root of 6/5 times the square root of 3/10. Well, when we multiply this together, we take advantage of the property up here, right? This property here. And we can multiply together, and that gives us the square root of 18 over 50. Well, it turns out that one I didn't intend this to be when I picked this example problem. That gives you just square root of 9 over square root of 25, which is square root of 9 over square root of 25, and you get 3/5 as your answer. So that one we didn't need to rationalize our denominator. So let's try another one where I don't pick such nice numbers. Let's try 8/7 times, let's say, 3/14. Okay, so now when we multiply across, we get 24 over the square root of 24. Man, I keep making the same mistake. Let's change this to 21st. Okay, so now we get square root of 16 over the square root of 21 times 7, which is 147. Well, that gives us, we always want to simplify first, 4, and 49 goes into 147 because there's a 7 here, and this is 7 times 3. So it goes into it 3 times, and so that means the denominator simplifies to 7 over the square root of 3. That is not rational in the denominator, so we have to rationalize on our denominator. So we need to multiply the top and the bottom by square root of 3 to rationalize, which gives me 4 times the square root of 3 over, 7 times square root of 3 times square root of 3 is just going to be 21. So 4 times the square root of 3 all over 21. One final case that I do want to discuss is a problem like this. If you've got 2 over the square root of 6, you need to rationalize this denominator. When you do that, you multiply by the square root of 6 over square root of 6, which gives you 2 times the square root of 6 all over 6. Because square root of 6 times square root of 6 is 6. Well, this can be simplified because we think about the rational parts as a fraction. 2 over 6 simplifies to 1 over 3. And so you end up with square root of 6 over 3. So if you ever have any problems where you need to look at the numerator and denominator at the end and decide, can I simplify this or not?